Okay, so one of the things then in terms of our descriptive statistics, which is new to us at Leaving Cert, is what we call interquartile range. Okay, so again, a lot of the statistic stuff really seems to be in the words. Quartile. Okay, quartile. There's four quartiles. Something can be split into four quartiles. It's four quarters, I suppose. So it's all to do with splitting the data into quarters. So if I have a particular data set, um, we'll just do the numbers from. Let me see. I'm going to skip 12. Yeah, okay, we'll go with those numbers there. So if I have these numbers here, I have 7 numbers there. The one we're used to is maybe getting what we the median, which is the point that's halfway into the data. So that's here. So that's halfway. Obviously, a half is the same as 2 quarters. So we would say that that is quartile 2. Okay, that's kind of looking at the second quartile. Okay, what we're going to be looking at is looking at the value that is 1/4 in, which is the first quartile, Q1, and the value that is 3/4 in, which is the third quartile, Q3. And we're going to look at the difference between those. Now, this can be really good for us in interpreting our data because we're looking at a range that's not just the biggest and the smallest. We're looking at data points that are a lot more central to my data. And I suppose what that can avoid is the influence of outliers. So an outlier, as we know, is a point that kind of it differs from the rest of my data. So it could be a point that's really, really high or a point that's really, really low. And obviously, if I'm calculating the range, one of those, if it's there, is going to factor into that calculation. Whereas if I go with interquartile range, I'm more likely to maybe avoid those potential outliers. And it can give me a better idea of the spread of the data. Now, how I calculate the interquartile range is quite similar actually to how we calculate the median. And we're actually just going to repeat our calculation again. So we are going to calculate the median of the data, so work out what the middle value is, find that middle value. We are then going to look at what is left over. Now, hilariously, I picked the wrong one here. I circled the wrong one. That's my mistake. Should have been the 5. I thought I was drawing the 5. Okay, should have been on the 5 there. So what we're going to do is we're going to calculate the median, which in this case is the 5. Let's look at how we would do that properly. So the proper way that we do to calculate the median is we take the number of numbers, we add 1, and we divide it all by 2. So that is 8 divided by 2, which is 4. What that means is that the fourth term is the median. And in this case, that's my number 5 here. Okay, so that's the median, that is the middle term. Okay, and if I have an odd number of terms, it will always have a middle number. What I'm then going to do is I'm going to look at the information or the data that's left. So here I'm looking at 2, 3, and 4. And then above that, I will be looking at 6, 10, and 12. To calculate the quartiles, Q1 and Q3, I am going to take the median of both of these. Now, the median is the middle term. So looking at it, I can actually see quite clearly that the middle term there is 3, and the middle term of these 3 is 10. Okay, I can actually see it fairly clearly, just even kind of observationally, just by looking at it. And that can be, I suppose, that's quite useful for me here. So that means that for this data set I've written out here, Q1 is 3 and Q2 or Q3 is 10. The interquartile range then comes from me subtracting those. So 10 minus 3, which is 7. So the interquartile range there is 7. If we look at the overall range would be 12 take away 2, which is 10. Okay, which is quite a larger range, and not necessarily due to any outliers or anything, obviously just because I'm taking the terms that are kind of that one step further away either side there. Okay, so really what we're doing is we calculate the median, we then ignore that median term, consider that to be the data now split into 2, and we calculate the median of what is left. Okay. So let's look at another example where we're doing that. So this example, Sam collected the marks of 10 people in a class test. The first thing, or I suppose the only other thing that I've forgotten to really emphasize, because it's part of our median, is to make sure that our terms are in order, which they are here. So the first part asks me to calculate the range. The overall range is just the biggest take away the smallest, which is 19 here, to get the interquartile range. Okay, we need to do a proper calculation here. So let's look at that. We need to find the median first. The median is the middle term. So to find the middle term, we take however many terms there are, we add 1, and we divide by 2. That is 11 divided by 2, which is 5.5. Now, obviously, there is no term there, so what that tells me is that the middle term is going to be between the 5th and the 6th term. Okay, because we know the median doesn't have to be one of the terms that is in the data set. It just has to be a middle value. So we're going to look between the 5th and the 6th term here. That's going to be between 18 and 20. Okay, so let's take an average 18 plus 20. We could probably work it out without actually adding them and working it out that way, but the median here is going to be 19. Now that we've calculated that, we are going to ignore our median and we are going to take our data, which has been split into kind of the two halves here now. And we are going to use this now to calculate my quartiles. So if we just take the blue section here, 6, 12, 15, 15, and 18, there are 5 terms in this data set. There are 5 terms in this data set. And the middle term would be the 3rd term. Okay, if I wanted to calculate it properly, 5 plus 1 is 6, divided by 2 is 3. If we look at the pink set here, it was 20, 20, 20, 22, 25. So the middle term there is 20. My interquartile range then is Q3 minus Q1. So Q3 here is 20 minus Q1 is 15, which is 5. Okay. Now, part 4 of this question, I know I've skipped a part, it's gone, the numbers are all off, but the part here that we're going to next is which of the averages or ranges is most appropriate. So we're just focusing on the range. So which of these ranges is most appropriate for this data set? And really what this comes down to is going to be outliers. Okay, if we have outliers, the range is always going to be affected by this. So therefore the interquartile range is often considered to be more accurate. Even without outliers, the interquartile range could be seen as being more accurate than the normal range. So here I would probably say that the interquartile range is more accurate because we have one outlier, which is the 6 here. Okay, the 6 is quite far from the next data point, which is a 12. So because of that, it is affecting the range overall. And we can see that in the calculation. When we calculate the range, it was 19. The interquartile range was 5. Okay, so that's actually quite a small range. And if we look at the data points here, from 12 to 25, yes, it is 13. It is definitely a larger range than we have with the interquartile range, but it's definitely much closer than we have with the 5 there. Okay, so it's just kind of to be careful of that, I suppose. Even the 12 could be considered to be fairly low as far as the things go here. So I would say the interquartile range would be a more accurate one there. So the main takeaway really from this video is just making sure you're able to calculate your interquartile range. So we do it by calculating the median first and then taking what is left of the data, ignoring that median, but taking basically the two halves, I suppose, of the data there and using that to calculate our overall median. And that should allow us to find the two quartiles, Q1 and Q3, and then we can go from there then to calculate the interquartile range.